this is a whole lot of graphing. Okay? This is all a lot of graphing and shading. We plot, we find all that stuff just like we normally do. There's more graphic coming around here soon. We plot things like we normally do. We find intercepts if we have to. Still need more graphic coming around? Send it around that way for me too. But here's the deal. Two ways to go about doing this. When we're setting these things up, we all know how to graph when we're on that good old-fashioned y equals mx plus b, correct? All right. So we can set it up that way. I'm going to go negative 2y is less than or equal to negative 4x plus 8. All I did is just move stuff over. And then at that point, you have to get rid of the coefficient in front of the y variable. Do we agree? What do you do? Divide and flip. Very good. Why do I flip this case? Excellent. Remember, whenever you multiply or divide by a negative on both sides, you've got to flip the inequality. So y is now greater than or equal to 2x minus 4. Okay? You recording? Yeah. So now I go ahead and plot. I start at negative 4, and I walk my slope of 2. And now comes the fun part. Is this a solid or a dotted line? Remember that? No. Okay. This is a solid line, and why is it solid? Because it's less than or equal to. So there's a couple of tricks to remember. When you are graphing inequalities, if it's a less than or equal to or a greater than or equal to, it's a solid line. If it is just a less than or a greater than, it's a dotted line. It's kind of like the same principle of how we had open and closed dots. We had closed dots when it was equal to, and we had open dots when it was just less than. It's the exact same principle, but we're just making it within two variables. That's why we have these lines. So now all I did here was just connect my dots, but I'm not done. We have to shade. Okay? We have to shade the graph. Now, you've done this in the past, and remember, the trick is when you're shading, is that you have to pick a point that is not on that graph. And what is a point that is not on that graph that is a very, very, very easy coordinate to use? 0. 0, 0. Very good. So, is 0, 0 on the graph? Oh, I'll give you that. 0, 0 is not on the line. So, 0, 0, the point here, easiest things to use, you guys. You're just like me. That point is on one side of the graph here, right? So the line that we have has cut the plane in half. You ever heard the term called half planes? You guys remember what a plane is in geometry? All right, a plane in geometry is a flat surface that extends out in all directions. Okay? A real simple idea of a plane is an XY grid because it's going up and down, left and right. So that's your two directions in infinite space. What this line does is it cuts it into two parts. Now, what we do with this point, this what we call a test point, is we're checking to see if I need to shade it here or here. And when you're shading these things, you always shade towards the truth. You want to cover it up. You want to think conspiracies. So what you do is you go back. Ah, I see what you did there. That's good. I like that. But boom. Anyway, so you take our test point.
That was
Good.
That was good.
So I'm not the only one with really bad jokes. Here's your test point. You tested it the ordered pairs, so it's 4 times 0 minus 2 times 0, smaller than or equal to 8. Notice how I always go back to the original equation. That's the trick. Just always go back to the original inequality. You're checking to see if it's a true or a false statement. So if it's true, we shade towards it. And that's all you have to do for shading. That's it. You don't have to sit there and color it in and make it all nice and dark. As long as there's some sort of a shade going in the correct direction, you're fine. If it happened to be false on that side, I would have shaded the other direction. Okay? So that means any point that I pick within the shaded region will make this a true statement. All you're doing is just picking a really, really, really easy one to try. And more often than not, you'll be able to use 0, 0, unless you go through the origin. Then you pick something like 2, 2 or 5, 5. Something that's very, very easy to use. Okay? I know you've seen this before, right? So it shouldn't take us very long to get through it. Try another one. Yeah, well, I'm not going to do all of them.
Is 5 just blank?
What's that?
Question 5 just like this?
No, I just hadn't finished it yet. I'm going to go back to it. I'm just going to start with slopes first. So in this case here, I have y is greater than 2x minus 1. I'm sorry, 2/3 x, excuse me. Y is greater than 2/3 x minus 1. So I start with my graph. If you want to just throw your homework on the desk, it's fine. I think it's underneath the stapler. Your friends didn't, care enough to hand it in for you. I just threw them all under the bus there. And you missed out. That's very great humor. I sense the sarcasm. So once again, we start at -1, and you walk your slope with 2/3. Is this going to be a solid or a dotted line? Dotted. Does it go through the origin? Nope. So my test point is going to be is 0 greater than 2/3 times 0 minus 1. Is 0 bigger than -1? True statement? And I just shade it. What's that? Good. All right. Oh, Mr. Taves, you got a good joke. Oh. Cover. You know how you want to cover the truth? It's a conspiracy. Well, we are plotting.
I thought you said a good joke.
Yeah, all right, fine. You win. It's not as funny the second time around.
Then people aren't gonna take you at face value.
Still not as good as. Did you finally get a mirror? See, I still got a joke at the second time. For that. You didn't.
I'm so hurt.
Single time.
I'm so hurt. Bully.
Isn't there a teacher out bully report?
There is now.
Wow, yeah.
Does this change if we have horizontal or vertical lines? No, it does not. So x greater than 5, is that a horizontal or a vertical line? It's a vertical. Okay, because x equal, very good, it's an x equal number. These rules don't change. So it's an x equal number. And it just goes through 5. Will that be a solid or a dotted line through 5? Got it. And which side of that are numbers larger than 5? On the left or the right?
That's
This side.
Oh, that's why my dress is. Hold on.
What's that?
I was like, why does it say negative on this side and then a 5?
Oh, you have it upside down? Oh, did I hole punch it wrong?
Oh, yeah.
Whatever. I didn't realize
It was right on this side.
it was right on one side but not on the other? Oh, that's weird. What?
No, when you
Had it upside down.
turn it, I just had it upside down.
Oh.
Yeah, I did too. Okay,
Let's just try a couple more. Because let's see, we've done 1, 2, 3. We got 3 more spots. Try these 2. Then I'll probably just give you some problems. We'll call it a day. Because like I said, I didn't think that 2-6 would take us very long to get through. And then that way we can start 2-7 tomorrow, or excuse me, 2-8 tomorrow. And 2-8 will give us will probably, I think, to be on the safe side, we'll plan out for 2 days on that. Because we'll do the same idea like we did with piecewise, where we spend a day graphing, then we'll spend the day writing equations. I think that's the best idea for 2-8 as well. So I'm starting to lean more towards our test then. It'll be on Wednesday. Okay? Our test will be Wednesday. And don't freak out because it's a Wednesday. Oh, days are short. I think they're like 1 minute regular class periods with 1 or 2 minutes shorter. That's it. So you'll have plenty of time to finish the test. No. Is it June yet?
I wish.
All right, let's check them. So, with any luck, you get, let's see, negative 3y, negative 2x, 6, y is greater than 2/3, x minus 2. I seem to lose count sometimes, so I'm sorry. Is that a solid or a dotted?
Yeah, color the top one.
Test it. Is 0 minus 0 smaller than 6? Okay? You don't have to show the test if you don't want to. It's not the end of the world. It's just hope. So basically think of it this way. You have a 50-50 chance of getting it right. Choose wisely. And then the last one, hopefully you got y is less than or equal to negative 1/5 x minus 2. Yeah. You always go back to the original equation. That's why. You always go back to the original. You always test the original. Always, always, always. But then if you did that, though, isn't 0 bigger than negative 2?
Yeah, it's not.
0 is bigger than negative 2. Would you rather have nothing or give me $2?
I'd rather receive $2.
Right. All right. Same idea on the other side. Start at negative 2, walk your slope, negative 1/5. This one's a solid.
You know, my graph's like this.
I did that right? Right? Yeah. Okay. I heard someone say wait. I wanted. A lot of times if someone goes wait, that means I screwed up. So just want to make sure.
Wouldn't it be 1 as a negative? Shouldn't it?
It is negative 1. Then I divided by 5.
No, because it's a negative 1/5 and you're doing times
Negative
negative
five.
5. So shouldn't that? Oh, it's minus 2.
Okay. Is 0 plus 0 smaller than negative 10? No. Finally, we have a false statement. It was false up top, which means it's true below. Okay?
I love this shape.
And that's what this does. The important part of being able to do these shading graphs like this, ladies and gentlemen, is that when we get into chapter 3, we use multiple shading graphs as what we call a constraint problem. We use it in what's called linear programming. We're going to find maximum and minimum functions by bounded areas. Yes, sir.
You didn't switch the sign.
Did I divide by a negative? Correct. You only switch the sign if you multiply or divide by a negative. It does not matter that the sign, when you move this stuff over, because when I did this, I had 5y is less than or equal to negative x minus 10. It doesn't matter that the x is already negative. What happens is, as long as the coefficient of the y value isn't negative, it doesn't matter.
So only if the y value coefficient is
Correct. It's the only time you got to worry about it. It's the only time you got to worry about it. Okay? No big deals? All right, let's get you some homework.
It's okay.
Let's see, this is 2.8. Oh, no, that's not 2.8, it's 2.6. Excuse me. Oh, I just deleted out of the website. I know, it's
This is why we can't have nice things. No, this is one. No homework.
No homework.
Yeah, no homework. Where's mine? Isn't it right there? Math 13, VHS. Sorry, Mr. Murphy. We don't.
No, that's my YouTube thing.
Shouldn't your YouTube have like a link down to the site?
That would make too much sense.
Video?
Oh, there it is.
Like it was tomorrow, so tomorrow we'll get back to the
Section 2.6. Let's do the following. This would be page 112. Page 112, let's do numbers 36 through, how many pieces of graph? How many graphs are on here? 6. 36 through 44. All you're doing is graphing tonight. There's 9 of them,
36 through.
which means all you need to have is one sheet of paper. You can do your work, move your algebra stuff around. Don't freak out if you got fractional intercepts and stuff like that. Just do your best guess. I'm not going to sit there with the micrometer and measure everything out. You just want to get a rough idea of what's going on. Remember, when we talk about tests and quizzes, there'll be nicer intercepts and whatnot. Sir?
What page?
This is on page 112. 36 through 44. Okay?
I'm scared.
So it's page 112. All right?